Welcome to Study Loop.
Here for the solution. For the part A, draw the free body diagram of collar showing applied forces. This is the free body diagram. This is the force F and angle 30 degree x axis y direction. Now consider the equilibrium of forces on the collar in y direction, that N equal to W cos 30 degree. The forces involved on the collar are the weight of collar acting downwards. The sine component of weight does work while cosine component of weight does no work, since the force is normal to the direction of motion. Also, the normal reaction exerted does no work. Assume the spring is compresses to its maximum displacement. Also, the collar is at rest at the start and at the end. Apply the work energy principle for the collar, that half kx square plus w sine 30 degree L plus x minus fl plus x equal to 0. Here k is the spring constant, x is the spring displacement, and L is the distance from the free of the spring to the collar. Substitute mu n for f. Here by substituting we get half kx square plus w sine 30 degree L plus x minus mu n 1 plus x equal to 0. Here mu is the coefficient of kinetic friction. Now substitute w sine 30 degree for n, and we get minus half kx square plus w sine 30 degree L plus x minus mu w cos 30 degree L plus x equal to 0. Now substitute 60 lb per feet for k and 5 inches for x and 7.5 lb for w and 18 inches for L. Hereby substituting the value we get minus half 60 lb per feet multiplied by 5 inches multiplied by 1 feet per 12 inches whole square plus 7.5 lb multiplied by sin 30 degree 18 inches plus 5 inches multiplied by 1 feet by 12 inches minus mu multiplied by 7.5 lb multiplied by cos 30 degree 18 inches plus 5 inches multiplied by 1 feet by 12 inches is equal to 0. From here, by solving this, we get minus 5.2803 plus 7.1875 minus 12.449 mu equal to 0, and from here we get mu equal to 0.159. Therefore, the coefficient of kinetic friction is 0.159. Now for the part B. The maximum velocity of the collar is reached when the collar is about to touch the spring, as when it touches the spring the velocity gets decreased. Apply the work energy principle for the collar when it travels a distance of L. W sin 30 degree L minus FL equal to half mv square. Substitute W by G from W for M. Then we get W sin 30 degree L minus FL equal to W by 2G V square. Here G is the acceleration due to gravity. Substitute mu W cos 30 degree for F. Then we get W sin 30 degree L minus mu W cos 30 degree L W by 2G V square. Now substitute 7.5 lb for W and 32.2 feet per second square for G and 18 inches for L. Then we get 7.5 multiplied by sin 30 degree 18 inches multiplied by 1 feet by 12 inches minus 0.59 multiplied by 7.5 multiplied by cos 30 degree 18 inches multiplied by 1 feet per 12 inches is equal to 7.5 divided by 2 multiplied by 32.2 v square. By solving this we get 5.625 minus 1.549 equal to 0.1165 v square, and from here we get v equal to 5.91 feet per second. Therefore, the maximum speed of the collar is 5.91 feet per second. So this is the complete solution, step by step in detail. Please go through this. Thank you.